What's going on, guys? In this video we are going to see how to prove this proposition number 5. Now here the proposition number 5 says for all x belongs to real number, their existent n belongs to z such that n minus 1 is less than x less than or equal to n. Okay, now let's see how to prove this one. First, okay, let's write the proof. First we are going to define a set. We define a set. The set is going to be s is equal to k belongs to integer where x is less than or equal to k and x equal to given. Their existent n belongs to integer, that's given right here, and we know that x is less than n and a is equal to 1 is greater than 0. Okay, let's continue. B is equal to x, a is equal to sets b is equal to x, and then we know that if it's na, that's going to be greater than b, because you can see x is less than n, and if a is less than or a is equal to 1, that's greater than 0, and we know that b is equal to x, so na is greater than b, and from this one we can say n is greater than x. Okay, let's continue here, and here we are going to use Archimedean property, like S is not an empty set, so by Archimedean property let us apply Archimedean property for a is equal to 1 is greater than 0 and b is equal to x. Then their existent n belongs to n such that na is greater than b and n times 1 is greater than x, n is greater than x, then S is not an empty set. Now we need to show that S is bounded below. S is bounded below. To do this again, we are using Archimedean property for a is equal to 1 and b is equal to negative x. Then their existent m belongs to n such that m times a is greater than b, m times 1 is greater than minus x, m is greater than minus x, minus m is less than x. This is fixed. Okay, let's continue here. I get rid of these parts. Okay, we know that minus x is less than x. Also, let's continue here. Also, minus m is below bound for s. Below bound for s. Now by proposition number 1, now by proposition number 1, if you don't know what is proposition number 1, I have made all the previous proposition from 1 to 4. You can just check it out in my If you search in my channel, you will find it. Proposition number 1, S has a minimum, like S has a minimum like n is equal to minimum S, therefore x is less than or equal to n. Now we need to show n minus 1 is less than x. Okay, let's continue here. Okay, I use different color. Here we argue by contradiction. Suppose x is less than or equal to n minus 1. N minus 1 belongs to S. So this one is not true. This is a contradiction because this is a contradiction because n minus 1 is less than n, that's equal to minimum of S. Okay, that's the final thing. And I hope you guys find this video helpful, and if you are trying to learn discrete mathematics, there are a bunch of videos in my playlist. I hope you guys watch that too, and don't forget to subscribe. See you next time.